All right. But some of us didn't see this in behavior. Can someone explain to us how they got this in behavior? Okay, but how did they make a graph? Okay, so something about leading coefficient and which exponent?
The highest.
Oh, that's right. Be careful, because I'm pretty sure those who did not get this as their answer were looking at this, right? But the leading coefficient goes on the highest exponent on the degree. Which of these, what is the degree? The 6. So the leading coefficient is that 2. I will point this out. Traditionally, when you do standard form, you actually go from the highest power down to the lowest power. So traditionally, we would write it like this. And that's why that 2 would be considered our leading coefficient. So what does that tell us? Looking at that highest power, that degree, and that leading coefficient. Okay, 1 is positive. There's something else. It's even, right? And I will always remind students, like, I don't ever try to sketch that out because I don't know what that looks like off the top of my head. But what is the most basic even degree polynomial? 2. A parabola, second degree, right? So either it looks like this, or it looks like this.
That's what I meant saying too.
Say again? How do you know it's this first one?
It's positive.
Right. If A is positive, then the parabola is concave up. Now that's not a parabola, but it is still an even degree polynomial, so I know it has the same end behavior. Remember, if it's an even degree, the end behaviors are the same, and if it's an odd degree, the end behaviors are different. They're opposites. Questions, comments, concerns about that bell ringer? Going once.
Which one was the answer?
No, I mean, I wrote the correct answer. That one was right.
Which one is it?
The ones that are...
I don't know which one it is. I can't see. All I see is what you wrote. I'm saying which one up there.
Which of these?
Yes.
These!
She's talking about which bar, I guess.
Like, you can't see what I wrote?
No, it's okay. I got
She
it.
can't see the bars from like the equation
I know.
on the thing.
These are the...
So I'm saying which one.
Which
like,
bars?
From the choices.
The one with 10 and
The
11.
second one and the fourth one.
Okay.
Yeah, that's what I said. It's the most common responses. The ones I wrote up here. No, she can see what I wrote. That was what she kept saying. That's why I was confused. I wrote the ones that had the most common responses. You good with that now? Zany.
So, the highest exponent.
It's called a leading coefficient because it's the coefficient on the term with the highest exponent. And that term with the highest exponent determines the degree. I don't have an answer. Okay, fair enough. I'll try my best.
For the leading coefficient, is it the leading coefficient with the highest exponent, or is it the first?
So the leading coefficient is always defined as the coefficient with the term with the highest exponent, right? Because the standard way to write it is always the highest exponent first and then down. But that's why I wrote it like this, because I wanted y'all to think through it, not just always assume it's right there. Because sometimes we might have to rewrite it so that it's highest power to the lowest. And then literally now, when you rewrite it the correct way, it is the first coefficient, or the leading coefficient. So good question there. All right, so here's our agenda. Apparently I just ignored the agenda and forgot to update this slide. I promise I updated other things. But we're working on section 2 today. We should finish it and start section 3 from this lesson 3 and hopefully get into the section 4. But what we're trying to do is apply polynomials to real world context. That's really what activity 1 from this lesson was all about. When we looked at that quartic model that was representing the data about frog eggs, I think. Does that sound familiar? Yes? Okay. So we're looking at polynomials in real world context and letting that be a jump start into polynomials in general. And we're furthering our understanding of the characteristics of polynomial functions. That's the majority of what we're looking at today. So what characteristics should we be thinking about?
The in
In behavior, definitely. What other characteristics?
the zeros, the intercepts.
The zeros, the degree, intercepts, what? Intervals of increasing and decreasing, which gives us the what? Relative max and min, right? And we'll get into the idea of absolute as well. Don't forget, because I heard Clay say intercepts, but which intercepts are you referring to? Oh, and we need x and y intercepts, right? And here's an important question. Do we need to distinguish x-intercepts from zeros?
Yes.
Why is that?
Because the amount of x-intercepts and zeros don't have to be the same.
Okay, why do the number of x-intercepts and zeros not have to be the same?
Because there could be imaginary zeros.
We can have imaginary zeros. What else? Can we have a multiplicity of 2? Or a multiplicity of 3? Or a multiplicity of 4? Which means we'd only have one x-intercept there, but it would be counted as multiple zeros, right? So don't forget, we can't just talk about zeros. We can't just talk about x-intercepts. We have to look at both of them because some zeros are imaginary. We won't see them on the x-axis. Some zeros would come with multiplicities, so we'd only see them once on the x-axis, but they're actually happening multiple times. Oh man, y'all forgot the first two characteristics that we always want to think about. Anyone know?
Positive and negative, even and odd.
Let me run through what we said so far. Degree, x-intercepts, y-intercepts, zero, intervals of increase and decrease, relative max and min, in behavior. Huh? Oh, domain and range. That might be important as well. And by might, I mean, yes, it's important. Sorry, Tristan, if you said it and I missed it. Okay, we didn't finish this yesterday in class with my other class, but did we finish number 6 in here? So we're on number 7?
Yes.
Yes? Okay. So, sorry you feel this way.
No, turn it
Like,
down.
turn up the air so that more air is blowing and it gets cooler.
Nah, I wanted to be 60 here.
Alright, so, right now we're looking at number 7. I will point this out with number 7. I wish I had told y'all to hold on to those pieces of paper so that you could create polynomials with this in behavior. But yesterday we looked with numbers 5 and 6 at polynomials with even degree in behavior. Now we're looking at odd. So what I want us to do is I want y'all to come up as a small group with one polynomial that has this in behavior, one polynomial with this in behavior, and then I want you to answer questions A, C, and D for number 8. You're going to do this at boards. You'll notice, I think that's from first block, but I feel like y'all are fairly responsible. I'll let you choose where you go to work today. You need to be, not quite yet, you need a vertical non-permanent surface is what we in the education will call it because it's vertical and you can write on it and erase it, right? So you can erase mistakes, but you each need to come up with one graph, or as a group come up with one graph of each of those in behaviors. Is that clear? Draw your graphs. No. Yeah. Put those up on the board and answer questions A through D. And break.
Oh, yeah. I'm baseball coach. Football. I've never lost. Alright, so what we do is we spray the towel, not the board.
There you go. Come on, Zany. Stand up, move around, get that blood flowing. Wake up a little bit. Yes. There are, but it's not good for a chocolate. At least that's what I've heard. They could have lied. I need to do some research.
You gotta explain your answer.
Well, I mean, my explanation is I've been told I might have been lied to, but.
Oh, don't start putting that on. But I don't know, he might have lied to me.
Hey, Amari, Alex, your group's over there. Bring your stuff over.
Not Amari, Stasia.
Deja, sorry. I said Amari, didn't I? Alright, your group's right there. Talk with them.
Because they up there doing.
Hey, by the way, don't go where the projection is just because that's where I'm gonna write later. Yeah, go on this left-hand side, on the left-hand side of that dash line.
Start over here and go this.
Yeah, I'll say that y'all have a lot of space. Like, do one graph on the left-hand side, do one graph on the right-hand side. Guys, come on, give me something. Give me more gusto with your polynomials with those invade, right? All right. Come on, guys. Let's come on. Come on. Y'all are making this way too complicated. Let's go. Let's go. Let's go, guys. I'm going to give y'all a maximum of 5 minutes from now to get your graphs up there and to get A, C, and D answered.
It looks like
The left-hand side was fine.
how do you want?
You draw it, Tallywhack.
Can you what the? You can go ahead and draw the other graph. Because we have to have one like that and one like that.
This you gotta answer AC.
Okay, are y'all actually engaging all four of us? Let's keep going. I will point on that left-hand graph just here. Does anyone see a problem? It's not even straight. The right-hand side was fine. I mean, as I said, look at the left-hand side. What's that arrow doing? Which direction is it going? It's going to the right. It should be going slightly to the nice smooth curve up to the left. Start answering A, C, and D. It was so bad. Hey guys, really quickly, just to point out on number 3, listen, or not 3, C, it's saying what are the possible x-intercepts. So if you think about taking that x-axis and shifting it up and down, how many x-intercepts could that graph have?
Y'all, we need to answer the questions while we too worried about drawing. Y'all were about to draw.
Why are there 5 people in this group right here? Where are you supposed to be, Chelsea? So who's not supposed to be over here? Jordan, you're supposed to be in that group.
21. You do something.
You worried about drawing? Use the axis to describe the polynomial number of possible.
You're with that group. It was on the board when you walked in, Jordan. You are with group 5. Over there. A, C, and D.
Oh, I'm sorry, dude.
Use the axis to describe the polynomial number of
Anyone know what the extreme is?
It's like
Alright guys, just a couple more minutes. Let's get those answers to A, C, and D up there.
What we talked about yesterday? You can have multiple numbers. You got.
they both change
We actually
That's a fun one.
What is
She has it's one more than just
Five, four, three, two, one. And it's here. Four different times. Okay. Consider that
So is it like saving
how many times is what function?
Wait, how many days? I don't know, because I was here tomorrow. I'm trying to think, I know.
It's more like a good job.
60 more seconds to get our final answers up on the board. 60 more seconds.
I don't even know you. Tristan, you legit stole my basketball goal out my backyard.
Sorry about that. Did you ever watch Mary Poppins growing up?
I've never seen that.
Oh, the
Wow, man.
Seriously?
I haven't seen it in a
Have you
long
seen
time.
Bruce
I
Snow?
could be wrong.
When they go
Oh, yeah,
into the
yeah,
picture and the Dick Van Dyke's there and he pulls his pants down on his legs, so he's like, actually I don't think stay up here, but then it's long here. I don't know. And he Penguin walks it. Anyways, all right, let's get started. If you're still working, I appreciate the work, but let's get seated and start talking through some of these things, okay? Because the whole thing is, and I need to always remind myself this and remind students, or remember to say this to students, what is mathematics? Study of patterns and relationships. I want to point out, if you look at part E, what does it ask?
What patterns?
What patterns do you notice, right? So we want to get to the idea of looking at these things and start talking about some patterns that we notice, right? So when I look at this function, any idea what degree it might be?
It could be 3 or 5.
Maybe a 3. I mean, like looking at it, most likely it's probably a 3, right? Third degree. 2 extrema. By the way, really quickly, just because, sorry, it does bug me because I took Latin.
You took Latin?
Yeah, in high school.
Is it extreme? Was it like required or like fun?
You could either take Spanish, Latin, French, German,
or Mexican.
or Chinese. Huh?
Chinese? I would assume Chinese.
No. Anyways, really quickly, look, hey guys,
9.
shh.
That's German.
Extremum, that's singular. Extrema, with that A at the end, that's plural. Okay? Just like, you don't know the word data, right? You don't know data is already plural, right? If it's one piece of information, it's datum. D-A-T-U-M.
I did not know that.
Yep.
I got all the data.
What? Yeah. Right. In Latin, they call it the declensions. I don't remember what they call that in Spanish, but there's 5 different declensions, and different words have different declensions, yada, yada, yada. And I think everyone knows, like, most Romance languages have feminine and masculine words,
Yes,
right?
I hate that.
German
Yeah.
has feminine and masculine, but it's not very romantic.
She speaks fluent German.
Really?
Used to be able to. I
Interesting.
forgot it now.
Yeah. But the different declensions typically go with different feminine versus masculine words. All right. Moving beyond that, though, right? So cubic, we see 2 extrema. This, what type of polynomial might this one be? So 5th degree, 6th degree. I will point this out. Can anyone look at this and immediately know it cannot be 6th degree? the end behavior, right? If it was 6th degree, even degree would be the same in either direction, right? Goes in different directions with that end behavior. I will say, looking at it, more than likely it's 5th degree based on what information? If you look right here, based on, it depends on where the x-axis is, right? But I see 1, 2, 3, 4, 5 x-intercepts, right? So probably a 5th degree, right? I see a lot of traditional cubics, right? Again, 2 extrema. I gotta ask though, when I talk about the extrema, has anyone noticed a pattern? I'm trying to look around the room, see if anyone did anything different. Does anyone notice a pattern for the number of extrema? Well, they would be, yeah, I guess they would be multiples of 2. So it could be 2, it could be 4, 6.
It's one less than something. We talked about it yesterday.
The number of extrema would be 1 less than, there's 2 different things we could look at, right? 1, the number of x-intercepts, or the number of, the number of x-intercepts or the number of zeros. It would be 1 less, or it can be 1 less, it could be less than that though. So yeah, I see 3 x-intercepts, 2 extrema, right? 1 relative max, 1 relative min. Here I see 1, 2, 3, 4, 5 zeros, so 5th degree, and I see 4 extrema, right? So the maximum number of extrema is 1 less than the zeros, or which matches the, not always, degree. There you go. That's what I want us to notice, and so we're going to talk about a couple of things in a second with that, but I will point this out. If I have, what type of function would this be? That'd be cubic as well, wouldn't it?
Yes.
How many extrema does that have? It only has,
One extra.
does it?
No,
Oh my gosh.
it doesn't have any.
It doesn't have any.
But it only has one.
It has a maximum of 2 extrema, but this one has
No.
0. Remember, to be a maximum, it has to stop what? Right? That's how we get a maximum, is it stops increasing, starts to decrease. But I just want to point that out, right? So it is 2 extrema for this, but it could have 0. Anyone have an idea why?
Because it has one x-intercept.
It only has 1 x-intercept. Anyone know what the multiplicity of this x-intercept would be? It would have to be a multiplicity of 3 because it's cubic, so it has to have how many zeros? 3, right? Please note multiplicities and imaginary zeros can affect how many extrema we have. And with that in mind, let's say that I have x to the 5th, right? It doesn't matter what comes after it. How many extrema could it have? It could have 4 or 2 or 0. It has to come in pairs. Remember how we talked about those imaginary zeros yesterday coming in pairs? The extrema, 4, 2, 0. Notice the maximum is always 1 less than the degree. So does anyone know anything we might be able to write down under part E right now? I will say this,
Pairs.
sorry, I should have said this earlier. Go ahead and copy your graph down for each, copy both your graphs down in your book so that you have those notes. I'm going to try to come by and check to make sure every answer is correct. Okay, so graph yours, answer A through D in your book, and then we'll have a wrap-up discussion where you write stuff for E.
What about B?
B's is odd.
Answers look fine around the room, so you can copy down your answers for A through D, and then we're going to talk about E. Okay. So what patterns do you notice? The max number of extrema is what? Is 1 less than the degree, but we want to add in this extra note. It can always have less, and how do we know what the options less are?
Because, not invisible numbers, but imaginary numbers have to come in 2.
So it'd have to be always going by 2s, right? So 4, 2, 0, right? Fifth degree, it could have 4 extrema, or 2 extrema, or 0. So the max number of extrema is 1 less than the degree, but can be less by 2s, right? Alright, so fifth degree could have 4, 2, or 0. What is what? E.g. It's another Latin root. It means for example. Exemplar gratis, for example.
Speak a sentence in Latin right now, please.
Say again.
Say a sentence in Latin.
Oh, I don't know enough Latin. I remember phrases. No one speaks Latin.
What page?
No idea.
What?
It's been 13, 14 years since I've studied Latin. I just remember some phrases.
Like what?
There's some phrases and say something in Latin.
Id est is that is. That's another abbreviation some people use. It's IE. Harvard, their slogan or whatever is Veritas, meaning truth. That's all I remember off the top of my head. What? I'm pretty sure that's German.
That's not like Hogwarts, bro.
Seriously, you don't know what Mein Kampf is?
Book written by Hitler.
Yeah. Anyways, moving beyond that. So what about the x-intercepts? I'll point out some of us just wrote down how many x-intercepts there are, but like when I look here at this cubic, this group said, hey, there could be 3, 2, 1, or 0 x-intercepts, and then 5 to 0. Over there I see 1 to 6, and then 5, 4, 3, 2, 1, drawing different things out. Now, that means that for x-intercepts, there's a lot of options. But I do want us to look again, right? Could there be 3 x-intercepts? 1, 2, 3. Definitely, right? We're good with 3 x-intercepts. Could there be 2 x-intercepts? Can someone come draw it where we would see an x-axis so we can see 2? Can't do it? Come on with it. Well, I'm looking for 2 right now. Is that 2 x-intercepts? Ooh. One of those x-intercepts has a multiplicity of 2, so is 2 x-intercepts possible? 100%. Is 1 x-intercept possible? I guess so. Where? Come on with it. Would that only have 1 x-intercept? Yes.
Okay.
Is there an option or a place where I can have 0 x-intercepts? Oh, well, 1, be careful. We don't have lines keep going. We have curves or polynomials or functions. Yeah, can we have 0 x-intercepts in this case?
No.
I want to point this out. If it's an odd degree, we know the end behaviors are in opposite directions, right? So one of them goes down to negative infinity. One goes up to positive infinity. And that's a continuous function, right? There's no breaks in it. What has to be between negative infinity and positive infinity? What key number? 0, right? If we are looking at an odd degree, I know it has to go from negative infinity up to infinity, which means it has to go through the x-axis where we have zeros. So can you ever have 0 x-intercepts? So what pattern do we notice, right? The x-intercepts can be the degree or less, but what's the minimum?
One.
A minimum of 1 x-intercept.
We also have a pattern of one more than the extremes.
Yeah, you could add that in. And that makes sense though, because the number of extrema has to be, at most 1 less than the degree, and the degree and the number of zeros match. Yeah, so that's a good point, right? Now, I will point this out, Grace Ann. It doesn't have to be, because notice if I have imaginary zeros like this, I only have 1 x-intercept that's still 2 extrema. So it can be up to 1 more. Yeah. All right. What about when we talk about increasing and decreasing, right? Technically, I will point out the terms are the relative max and min, right? But we're talking about the intervals of increase and decrease. What's the relationship between the intervals of increase and decrease and everything else? So like here, right?
Rephrase that question.
Yeah, sorry. When we look at D, this group said that there are 3 intervals of increase and decrease, right? Over here, I do want to check this one. I see 1, 2, 3, 4, 5. I missed that. Here we have 3 intervals of increase and decrease, 3 intervals of increase and decrease. If I come over here, I see 1, 2, 3, 4, 5, 6. Oop, that's 7. And I missed this. I think there's 1, 2, 3, 4, 5, 6. That's 7. So update that if that was yours. I will point out we should know that it can't be 6 x-intercepts if we look, because everywhere it intersects in the 7th degree. But does anyone see a pattern yet? Oh wait, that was supposed to be 6. This was 1, 2, 7. Sorry. Anyone see a pattern yet? Aaliyah?
That it matches our degree.
Does it always match the degree? It's an important question.
Matches our x-intercept.
Matches the x-intercepts. I will say, sorry, I'm trying to think of an example.
Is one more than how many terms we have?
Well, it's 1 more than the number of extrema, is those terms, right? Sorry, I was trying to think of how to say that. But notice here, right, this would be probably a 5th degree. Yeah, it has to be more than a 3rd because of that little piece there. But when I think about it, there's only 1, 2, 3 intervals of increase and decrease. Does that make sense? And so when I look at it that way, what was your statement again? It had to be
the intervals were equal to
match the x-intercepts. Yeah, which I guess that does match the number of x-intercepts there. So let's see that I get it a little bit more complicated. All right. Notice how that has more intervals of increase and decrease, right? So it's less about the number of x-intercepts and more about the what? What determines how many x-intercepts we could have?
Zero.
And what determines how many zeros we have?
Degree.
The degree. Does that make sense? So what we want to note here is the most number of intervals of increase and decrease matches the degree. But I heard someone say this earlier, this is an important detail. what the number of intervals of increase and decrease is will always be one more than the number of, anyone else hear someone say? Intervals of increase and decrease will always be one more than the number of extrema. Every time. In order for it to change from increasing to decreasing, we have to hit a max. So what will definitely always be true is the number of intervals is one more than number of extrema. That is definitely going to be true. That will always be true, as far as I'm aware. Hopefully I'm not lying to you, but I'm 99% sure that that statement will always be true. Now I want to emphasize something. It's a lot of information, right? Do you want to memorize all that?
No.
I don't either. But if you understand it, you don't have to memorize it. You can apply it whenever. You need to know that information, but you want to understand it more than just memorize it. When you memorize things, you're going to struggle in my class. I cannot emphasize that enough. My class is a thinking class, not a memorizing class. So, one of the things I want to talk about while some of us are still taking notes is this. I was talking with one particular student yesterday, and I want y'all to clearly understand something, and I need to emphasize this more in the future. This book is not book work. Traditionally, if you think about book work or completing assignments, it's just, all right, I'm doing this thing to get it out of the way. These are your notes. This book work is learning, which means that we need to go back and study these notes, or put them in some form that we're used to studying. So I asked the student, well, how do you study? She was like, I don't know how to study for math. Well, here's the first thing. First off, she was talking about, well, I make note cards for my English and my history classes. You can make note cards for this class when it comes to key ideas. Like, you should be able to put the term quintic polynomial on a note card and have some details on the back and use it like a flashcard. You can do the same thing with the fundamental theorem of algebra, the equation of a line, y equals mx plus b, or point slope, y equals m times x minus x1 plus y1, things like that. You can do concepts and equations as flashcards, or Quizlets, or if you like making things into songs or physical motion, do that, but use your notes to build those things, huh? Necessal, right. Use your notes to do those things, but then also you have to take time to do practice problems. You got to know what the formulas are, you got to know what the concepts mean, and then you have to be able to apply it to graph things like that. And I need to teach that better, I think, moving forward, but that's how you do math. Some people study differently. Conceptually, I can just read through my notes and get the concepts, like I remember them well. But even then, I still had to practice them on practice problems. Some of us need flashcards, Quizlets, whatever. You choose what the best method is for you. But please understand, all these things in the book are not just do them and get them out of the way. These are learning activities for you to go back and study later. Okay, so hopefully that helps some of us find greater success second half of this quarter. But we'll talk more about those things moving forward. So this, I actually don't have the whole thing from the book on this because I didn't originally plan to go through it. And I started looking at it more and talking about it with first block, and I was like, dang, this really is better. Ms. Estel and I talked about not filling this all the way out because we didn't want you to just memorize this information, but I think writing out a couple of key details will help you study moving forward. For example, right, like here with cubics, they write out all possible end behaviors. I think that's goofy because then you're going to have to memorize those end behaviors. What can you do for a quartic? What can we write here to figure out what the end behavior is? Because I don't want to memorize all the end behaviors that are possible. What can I do? Can I just sketch out a quick graph? Right? Knowing that it's even, degree and paying attention to the leading coefficient, sketch a graph and do the behavior that way. That's what I would do. Even, degree, and pay attention to leading coefficient to sketch and determine end behavior. By the way, you'll see me abbreviate end behavior as EB pretty regularly. I don't know if I've done that before, but I will. Okay.
What's that thing before even?
It's a little star asterisk.
Okay.
I can just take that off if that makes you feel better. Alright, so I'm not going to memorize all the different end behaviors that are possible. I'm just going to sketch it out quickly and figure out the end behavior. Don't make it more complicated. I don't have an answer.
What is this preferred? Never mind.
Okay.
I figured it out.
Good, glad to hear it. Alright, I'll point out with a cubic, it says the possible number of x-intercepts is 3, 2, or 1. What about for a quartic? What would be the possible number of x-intercepts?
4 down?
4, 2,
Be careful. Quartic is what degree?
4.
4.
3.
So,
4, 3, 2, 3, 2, 1.
possible number of x-intercepts. So, is it not possible to get 0 x-intercepts for a quartic? I was saying, think about a quartic, right? It doesn't have to go from negative infinity to positive infinity. Is it possible to have 0 x-intercepts? Now, it doesn't matter how many x-intercepts. We know that the number of zeros is 4. Thank you. If it's 4th degree, we know the number of x-intercepts is 4. Or, sorry, ooh, that was wrong. The number of zeros is 4, but it had those number of x-intercepts. What are the number of possible extrema? 5? What? Look over there.
1.
3.
Talking about extrema. We have 3. Is it possible to have a different number of extrema? Yes? No? Maybe so? Anyone have a prediction about how I could sketch a quartic with only, well, I won't tell you how many, with a different number of extrema?
Yes.
I already had you two. Somebody else? Looks like we're scared. All right, Lee, I'll let you come up first. What did you say, Deja? Tristan, if you want to draw one at the same time, see to make a prediction, we can. Come on, Leah, Tristan, come on, both of y'all. Make a prediction. Let's go. I want a quartic that only has 1 extrema. Actually, not necessarily just 1. Something other than 3 extrema is really what it is. It's a good question. Leah, what do you think about that graph? What do y'all think? First off, how many extrema does it have? It just has 1, right? And I will say it's quartic. If you think about moving this x-axis up, right here, notice how it has 1 x-intercept here and it only has 1 here, but it has a multiplicity of 3, so that would be, what type of function? Quartic. How many extrema does it have? So it could have 3 or it could have 1. Hey, notice how far apart are 3 and 1? Oh yeah, because we can have imaginary roots and multiplicities, right? That's where that's coming from. Coming from imaginary roots and multiplicities. So the number of possible extrema for a quartic is 3 or 1. Remember, the maximum is 3, so it can only be less than that. So the option is 1 there for the number of extrema. Possible number of intervals of increase and decrease. So I see 1 decrease, 1 increase, 1 decrease, 1 increase, which is 4. But if I look over here, I see 2, right? So it could have 4, or it could have 2. Is it possible to go down another 2 and have 0 increase or decrease? No, because that means there would be nothing. Okay. So 4 or 2 for those extrema. Or for 4 or 2 for those intervals of increase and decrease. One thing I will point out is, right here, and this is again where they really go into a lot of detail showing every possible combination, but I don't think that that's fully necessary, because if you sketch it out, can't you see the combination right away? I know that there could be 4 increases and decreases, or there could be 2, and I know based on the in behavior how to sketch these things out. And that's what I would use, right? So this would just be decrease, then increase, decrease, then increase. That's how you could write that, right? Here, this would just be decrease and then increase. Okay? And so that's what we'd want to notice. All right, let's move to a quintic. I forgot to put quintics in here, and by that I mean I wasn't planning on talking about this table, so I am now. All right, quintics. Any questions what I would say here for in behavior? Because that says quartics, and we're now moving to quintics, which is the bottom section. Any guesses what I would put here for in behavior for quintics? Yeah, I would literally put the same thing. I would literally write same as info with quartics. I will say the only difference is it's a quintic, so the in behaviors will be opposite, right? This would be an odd degree, so the in behavior would be opposites. What about the possible number of x-intercepts? So no 0 this time?
0.
Yes, 0?
No, 0 could go in your opposites.
I would say, remember, with those odd degree, it has to go in opposite directions, right? So we will always have at least 1 x-intercept. All right? And I'll point this out, right? You can memorize all this information, but if you understand or make a note here, hey, the most equals the degree, and a minimum number of 1 because of this. That way you don't have to memorize it all, right? We just always know that the most number of x-intercepts is the degree, and for an odd, the minimum number is 1. But for an even degree, the minimum number is, right? We can have 0 x-intercepts. Those are things that we want to notice and be aware of, that we can have the maximum number of x-intercepts is always what the degree is. But for an odd degree polynomial, the minimum number is 1, and for an even degree, the minimum number is 0. Kennedy, have I put you to sleep over there? Man, she's out cold. I don't know how she sleeps like that. All right. Number of possible extrema for a quintic. 4 and 2. Or there's one more option. 0. For a remember, for the number of extrema, it can do something like that if there's a multiplicity of 5 right there. And so again, the extrema, the maximum number of extrema is always 1 less than the degree, and then the next possible is always 2 less.
So quintiles are the only ones that can have zero?
Say again.
They're the only ones that can have zero?
Odd degrees, yeah. Yeah, because if you think about an even degree, the maximum number of extrema would be, for the quartic, right, the max was 3. If I go 2 less, then I get 1. Well, I can't go 2 less than 1. Okay? Zane, can you get off your watch, please? Thank you. Possible intervals of increase and decrease. So how many possible intervals of increase and decrease can you have? You got how many? 5, right? Remember, the max matches the degree, so 5. What are some other options? 3 or 1. We literally see that example of 1 right here is just always increasing. It could be 3. Like this, right? Yep, that's 3. And that would be a quintic. Okay. So 5, 3, or 1, we want to notice that pattern of decreasing by 2s because, again, why are we getting the decreasing by 2s there? Because of what? Not invisible. Imaginary zeros. Yeah. All right. All right, so this first question here, 10a, what conclusions can you make about the domain and range of all even degree polynomials, right? So here's an example of an even degree. Here's the example of an even degree with the opposite in behavior. What conclusion should we start to make, hopefully, about the domain of even degree polynomials and really just any polynomial? Anybody? The domain is your x values. And so Tristan, what were you saying? So remember, when we talk about domain, we are specifically talking about which variable? The x. Will this keep going forever to the left? Yes. Will it keep going forever to the right? Yes. Does it have everything in between? That's a key detail people miss. When we talk about the x values, everywhere that we have on this smooth curve, there's an understood point. Every point has both an x and a... So there's this x value right there. This point has an x value right there. This point has an x value right there. And so everywhere has x values associated with it. In fact, it has every x value from negative infinity all the way to positive infinity. That's always going to be true for an even degree polynomial. Every time. But now let's talk about the range.
It has to have one real point.
Say again.
Wouldn't it have to have like one real point? I don't know what the technical term for that would be.
I think I know what you're saying. Does anyone know what she's referring to, Lexi?
The maximum or minimum?
There has to be what type of maximum or minimum?
Or absolute?
Yeah, look right here. Is there any point below that point?
No.
Yeah. So that is the absolute lowest y value, isn't it? So when it is a positive leading coefficient, I have an absolute minimum. And so when I talk about the range, it's actually going to start at some minimum value. And then what's the maximum y value going to be? I mean, look at it. Is it negative infinity? Please remember this. A lot of students get lost on this. When I talk about range, I'm only talking about the y. Domain is x horizontally. Range is the y. So whatever this minimum value is, but then if it's going forever up, the maximum is infinity. This is when it's a positive leading coefficient. Well, what if it's a negative leading coefficient?
Using the opposite, so negative infinity to an absolute max.
Okay, so negative infinity to an absolute max. Does anybody want to push back on that or ask a question about that? Bree, you good back there?
Mm-hmm.
Yeah?
No.
You got some good notes?
Nope.
Well, let's start fixing that. Unless you want to watch the video later and take notes that way. That sounds like a lot of work. All right, no questions, comments, concerns then? We're all comfy with that idea? All right. Part B, we're moving on to odd degree polynomials. Again, there's only two possible end behaviors for an odd degree. Doesn't matter how complicated and convoluted that odd degree polynomial gets. Man, that's a beautiful one right there. And so those are the two possible end behaviors. What do we see for domain? Okay, so one thing I want to clarify, I need y'all to pay attention to this. When we use this interval notation, the number that always goes first is the minimum value. So if I'm talking about the x values, looking at these two graphs, what is the minimum x value? Yeah, the x is always what's on the left. So the domain would still start as negative infinity, comma. And so if the left-hand part is minimum, the right-hand part is the
Maximum.
So what's the maximum x value?
Infinity.
Infinity. Yeah, I did too, all the way through high school and most of college. And then by the time I got to the end of like doing it for 6 or 7 years, I got comfortable with it.
Hey, don't what?
Infinity.
It looks so easy to
Oh,
draw,
mine's
it's
the
so
one called
complicated.
special ed.
Exactly. Like, why does it look
Clay.
so easy, but why is it so
90% of what you write is a special x. Like, it's a miracle I can read what you're writing. Yeah.
Told me I could work there,
Who told you that? Yes, that's about accurate.
not the
I think
only
I've seen
one.
1 or 2 words. But looking really quickly, I do want to point this out because I feel like this is another detail that gets lost on students sometimes. Please understand, this comma right here is super important. Because what I'm saying here is that that's the minimum value, right? That's saying that's the maximum value. So what's that comma indicating?
everything in between?
Everything in between, right? The minimum, the maximum, and then everything in between, right? That's what that comma indicates. That's why we call it an interval notation, because it's from that minimum all the way up to that maximum. Okay, range. Well, what always has to go first?
Negative.
The minimum, right? It doesn't matter on the left-hand side if it's going up. Remember, if we're talking about interval notation, we need the lowest, right? So it's always from a negative infinity up to a positive infinity, right? And that's what you have to be careful about. If I'm talking about range, I'm talking about from the lowest to the highest. Don't pay attention to end behavior there. It is just the lowest to the highest. And the beautiful part about an odd degree is it's always negative infinity to infinity, because those end behaviors go in opposite directions. Questions, comments, concerns? Going once, going twice. Sold. All right, here's number 11. I'm going to give y'all, I'm going to say 2 minutes to answer these 3 questions. Talk about it as a group, write an answer down, but don't stress it too much. And we'll talk about it as a whole class in a second, all right? So 2 minutes to answer these 3 questions. By the way, the answers are always either always, sometimes, or never. It's one of those 3 things, always, sometimes, or never. Looks like your body is making a really good drum, but I'd rather your brain make some, I don't know, more intelligent sounds.
It never